And after Cartesian product, we covered relations. Okay. So sets we have already discussed. Sets is nothing but a collection of numbers or well-defined objects with some conditions. Some conditions, the conditions are that order of appearance of the elements does not matter, and any element can appear at max only one time. It cannot appear two times, it cannot appear three times. Only one time representation is enough. Okay, so we defined sets and we defined three ways to write a set. First was statement form. It was a very rudimentary form. In curly bracket, you just simply write the property possessed by the elements of that set. Yes, Deepak, I am in Hyderabad. Okay, we will talk about all this after the class. Okay, last 5-10 minutes I will keep this. Uh, last 10 minutes I'll keep for this kind of discussion. But first, let's focus on the studies. So we defined three ways to write a set. The first was statement form. In the statement form, what we did in the curly bracket, we simply mentioned the properties possessed by the elements of the set. In the second, rooster form or the tabular form, it is the straightforward form in which in the curly bracket we simply directly denote the elements of the set. Whatever the elements we will directly write. That is the tabular form or the rooster form. And in the third form, that is the set builder form. And this set builder form is the very standard form, and it is used all over the world. Okay, it is used all over the world. In this, what we do, we denote all the elements by a single symbol, usually X, followed by colon or backslash. After that, we write the property possessed by the elements, and whole thing will be enclosed by in the curly brackets, right? So that's all we studied in the sets. After that, we came to subsets. Subset is nothing but a set. Now, first of all, subset is always defined with respect to another set. So set B is a subset of set A if all the elements of set B is also the element of set A. So set B is called the subset and set A is called the superset. This also we covered. Some observations in the form of notes. We also mentioned if a set has total n elements. Okay, if the set has total n elements, then total number of subsets will be 2 to the power n. We already saw. If a set has total n elements, if a set has total n elements, then it will have 2 to the power n subsets. And again in subsets, we studied two types of subsets. First is your proper subsets and second is your improper subsets. Improper subsets are nothing but the set itself and the null set. These two sets are called improper subset. That means if we take all the elements and if we don't take any element, these two extreme cases are called improper subsets. Rest all the subsets are known as proper subset, right? After that, we came into ordered pair. Ordered pair, I told you, by the name of the topic itself, you can understand. Pair, it means two. Ordered means order of appearance matter. Who is coming on the first place, who is coming on the second place, it matters, right? So I gave you the example of our coordinate of a point, x comma y. The first entry we already know, this is the x coordinate. The second coordinate, second entry we already know that it is the y coordinate, right? If we interchange, then the meaning will also change, right? So we already understood that what are the ordered pair. Then we defined Cartesian product. Cartesian product between the two sets we defined, let's say set A has some elements, set B has some elements. Then all the ordered pairs A comma B from set A to set B such that first element is coming from set A and second element is coming from set B. It is basically a set of all the ordered pair, and it is called Cartesian product, and it is denoted by, if you remember, A cross B. A cross B, it is denoted by. Now, after that, we came to relation. Relation is nothing but a subset of Cartesian product. Okay. If we rudimentally try to understand what a relation is, it is nothing but a connection between two elements or two objects. Okay. It is nothing but a connection between or relation between two objects or two elements. Right. And by the diagram also, we try to understand. Let's say this is your set A, this is your set B. Now 1, 2, 3, let's say, and this is your XY. Now, if one is connected with X, that is a relation. Let's say 2 is also connected with X, that is also a relation. Let's say 3 is connected with Y. Okay. So 1 comma X, 2 comma X, 3 comma Y, these are basically ordered pairs. And if you make a set, then it will be called a relation. Right? So relation is nothing but a subset of Cartesian product. Okay. So understand the sequence through which we have reached to relation. After that, we will come to functions also. Okay. So this is a recap. Now, based on how we are connecting elements of set A with the elements of set B, we define so many types of relations. Okay. Like in general life also, if all of you are student, then I can simply say that, let's say Charita, Chatuteja, Deepak, Santosh, Hanok, all are students of K. Venkana Junior College. So it is a relation in which first entry is the student, second entry is the college, right? If we define the relation between you guys, let's say Deepak and Santosh, you guys are batchmates. So first entry and second entry will be basically batchmates. Some of you might be friends. So I can define the relation of friends also. You can define the relation with respect to your parents also. The first entry is the son or the daughter, and the second entry is mother or father. So depending upon how we are connecting elements of set A with the elements of set B, we can define so many types of relation. And that's what we are going to study right now. And understand one thing, the topic I am covering today, it is a very easy topic, but every year, every year in JEE Main, exactly one question comes from this topic. It is a very easy question, but nobody properly understands it. So try to understand it, and I'm sure you can solve the question orally. It is one of the very less calculative question. Okay, it is a free question, but try to understand the concept first. Understand? Okay. So types of relations. Let's say we have two sets. Let's say set A and set B. Okay. Set A has some elements, set B also has some elements. Okay. Now, by the some of the relation you can easily understand just going by the name of the relation. First is empty relation. Empty relation. Now, we studied empty sets. Okay, we have already studied empty set. Now, what is empty set? When we are not taking any element, when there is no element in the set, that is the empty set. Similarly, empty relation is also the same. When there is no element in the set relation. See, relation is also set. Relation is also a set. Relation is nothing but a subset of the Cartesian product. So it is also a set which has ordered pair as elements, right? Now, if that relation has no element in it, then it is an empty relation. This is the concept. Now, if I try to put it in words, it means if no element of set A is connected with no element of set B, then it is a empty relation. Let's say this is your set A and it has element 1, 2, 3, and let's say this is set B and it has element, let's say 3, 5, 7. If there is no connection between these two sets, let's say one is not connected with any element, 2 is also not connected with any element, and 3 is also, let's say I'm taking this element 4, let's say 2, 4, 6. Okay, let's say I am not connecting any element with the set with the elements of set B, then it is an empty relation. For example, relation I'm defining from A to B such that A plus B is even, where A is element of A and B is element of B. What I'm doing? I'm defining a relation from set A to set B such that A plus B is even, where A is the element of set A and B is the element of set B. Now, can we have any ordered pair satisfying this property if A is 2, 4, 6 and B is 3, 5, 7? Can there be any connection? No, definitely. Because there are even numbers like 2 is even, 4 is even, 6 is also even, and 3, 5, 7, these are odd. If you add even and odd, you will always get odd numbers, right? So you have defined a relation, but there is no element in it. So you can definitely write R is equals to phi, or simply empty curly brackets, right? So it is called an empty relation. Why? Because you have defined a relation, but there is no element in it. So a relation in which no element of set A is connected with or you can use the better word related with any element of set B, then it is called an empty relation, right? It is easy to understood. Easy to understand from the name itself. Now, come to the other extreme part. Let's say I define universal relation. Universal relation. Now, in the universal relation, what we are doing? We are connecting every element of set A with the every element of set B. That means we are taking the Cartesian product itself. Let's say this is your set A, this is 2, 4, 6, and let's say this is set B, let's say this is 3, 5, 7, and I define a relation. Let's say this is your R1, and I define R2 as a relation from set A to set B such that A into B is even. Let's say I define a relation A into B is even, where A is element of set A and B is element of set B. Right? Now, can you see where A is the element of A and B is the element of B? Can you see all the elements of set A are connected with all the elements of set B? Because These are all even numbers. If you multiply any number with the even number, you will always get even number, right? So definitely 2 will be connected with 3. Similarly, 2 will be connected with 5 also. 2 will be connected with 7 also. Similarly, 4 is connected with 3, 4 is connected with 5, 4 is connected with 7, 6 is connected with 3, 5, and 7. That means all the elements are connected with all the elements of set B. So it is nothing but a Cartesian product itself. So universal relation is the relation in which all the elements of set A is related to all the elements of set B. Set B. Is it clear to everybody? The empty relation and the universal relation. Clear? Okay, quickly copy and I'll rub this off. Copied. Now, the third relation, identity relation. Identity relation. Okay. Now, first understand what is identity relation means. Okay. See, identity relation is nothing but an ordered pair, a set of ordered pair. Now, identity relation is nothing but whatever you take on the first entry will also be your second entry. Okay, whatever you take on the first entry, that will also be your second entry. That means if it is X, then it will also be X. If this is 1, this is also will be 1. If this is 2, then this is also will be 2. So try to understand what is an identity relation. Identity relation means when every element, every element is related to itself only. When every element is related to itself only. Okay, so I'll give you just one example. Let's say this is your set A, 1, 2, 3. So identity relation is defined from set A into itself. Okay, understand this. Identity relation is defined from set A to set A itself. We don't need any other set because we are talking about the relation between the number and with itself. Okay, we are relating the number with itself only. When every element is related to itself only, that means we don't need any other element. Okay, so all every time identity relation come, it means we are defining a relation from set A to set A itself. That means the first entry will be from set A and second entry will also be set A, right? But how they are connected? The first entry will also be the second entry. So understand this, when every element is related to itself only. So if set A is 1, 2, 3, and I'm defining a relation from set A to set A itself, then that means this is 1, 2, 3. This is also 1, 2, 3. That means this 1 is connected to 1 itself. 2 is connected to 2 itself. 3 is connected to 3 itself. Whenever this happens, it is called an identity relation. So identity relation, I'm defining from set A to A such that every element, or simply I can say A comma A, for all A is element of A. Okay, A comma A, for all A is element of A. That means every element of the relation will have the entries of the type A comma A. Okay, and this we have to do for all the elements. No elements of set A should be left out for this property. Okay, so if I define, let's say R1, R2 and R3, let's say R1 I'm defining 1 comma 1, 2 comma 2 and 3 comma 3. R2 I'm defining 1 comma 2, 1 comma 1, 2 comma 2, 3 comma 3, right? And R3 I'm defining 1 comma 1 and 2 comma 2. So tell me, out of R1, R2, R3, which one is your identity relation? R1 and R3, Vahini says. Hanok also says R1 and R3. Others are sleeping. Santosh, Deepak, Chatuteja, Charita, Tejasvi, wake up. This question will come into your exam. Chatuteja says R1, R3. Swati says R1, R3. So tell me one thing. Are you just copy pasting others' answers? Use your mind also. R1 and R2, Satvika says. Okay. Okay. I understand. See, first understand this language. When every element is related to itself, okay, that means no element of set A must be related to any other element other than itself. That we understood. But this only word, that means it has to be connected with itself, but it cannot be connected to any other element. Only means I can do only this thing. Okay. Any element can connect to itself only, not with any other element. So, first of all of you, message publicly. Don't reply privately to me. Open yourself to all the other students. Everybody makes mistakes, not an issue. But shying away or hiding your mistake, that's an issue. Because otherwise you will not be able to improve your mistakes. Anyway, if we look at R1, then we see, okay, first let's come to R2. In R2, we have 1 comma 1, 2 comma 2, 3 comma 3. That means every element of set A is connected to every element of set B. Yes, we know that. Sorry, every element of set A is connected to itself. In R2, 1 is connected to with 1, 2 is connected to 2, 3 is connected to 3. That property is satisfied. 1 is connected to 1, 2 is connected to 2, 3 is connected to 3. We understand that this property is satisfied. But this only word, this is not satisfied because 1 is related to 2 also. That means 1 is related to 2 also, which is not permissible in identity relation. So R2 is not an identity relation. Now in R3, if we see 1 is related to 1, 2 is related to 2, but it has to be happening for all the elements of A, set A. We cannot leave any element from this property. Okay, we have to do this for all the elements of set A. And if we see, we don't have the element 3 comma 3. So this is also not an identity relation. Okay, if I look at the R3, it simply means, okay, 1 is connected with 1, 2 is connected to 2, but 3 is not connected to 3. So that is not an identity relation. For identity relation, every element must be connected with itself and only. Okay, it has to be connected first itself and it cannot be connected to any other element. So R3 is not an identity relation. Now, if you look at the R1, then every element, 1 is connected to 1, 2 is connected to 2, 3 is connected to 3. Okay, it is connected to itself and it is not connected to any other event. That means this property is completely satisfied. So yes, R1 is your identity relation. R1 is your identity relation. Is it clear? Okay, good. So this one single line is very, very important. Okay. If you have copied, then let me know. In identity relation, every element is connected to itself. Copied? Now, similar type. थोड़ा धीरे कर दीजिए सर, थोड़ा धीरे कर दीजिए. Now, similar type of relation, I am also going to define. It is called reflexive relation. It is called reflexive relation. Now, reflexive relation also has the same property when every element is connected to itself. The only difference is this only word will not come in this case. Okay. The only difference is this only word is not coming in this case. That means, what does this mean? Every element is connected to itself, but we are not restricting it. It can be connected to other elements also. Try to understand this. Let's say this is your A. Okay. Now, if I define a relation, reflexive relation, every element is related to itself. That means 1 comma 1, 2 comma 2, 3 comma 3. Okay. This much is essential. At least this must be happening for this relation to be a reflexive relation. Okay. Every element must be connected with itself. But we are not using the word only. Okay. We use the word in our identity relation, but we are not using in reflexive relation. Now that means it can be connect, it must be connected with itself, but it can be connected with other elements also. That means if this property is satisfied, then I can add anything else. Let's say one is connected with, let's say two is connected with three. Okay, two is connected with three. My voice is low. Everybody please confirm quickly. Confirm my voice is okay or not. It's clear? Okay. Satvika, try to increase the volume of your phone. I think it will work. Okay, okay. Thank you. I think Satvika, try to increase the volume of your phone or use earphone. Your voice will be, my voice will be better. Okay. Okay. So first understand the concept of this reflexive relation. Every time student gets confused in this. In identity relation, we use the word only. And in reflexive, we are not using the word only. That means in the reflexive relation, every element must be connected to itself. That is the only requirement. After that, if anybody is doing anything else, then there is no problem. That means if after satisfying this property, one is connected to one, two is connected to two, three is connected to three. After satisfying this minimum property, if one is connected to any other element, no issue. Two is connected with any other element, there is no issue. At least this must be satisfied. Let me give you an example. Let's say you guys are preparing for JEE, IIT JEE, right? Now, your parents must be telling you, you must be studying all the time. Okay, your time must be devoted to studies only. Remember the word only. That means all day from morning to night, you will be only studying. Your time cannot be devoted to anything else. Only study. But let's say I tell you that whatever the homework all the teachers are providing you, all the classes that are happening, if you attend that much, if you do that much, that is enough for me. In the rest of the time, you can do anything. Okay, understand the difference? The first relation is your identity relation, in which it says you can do this much only. And in the second thing just that I am saying, you need to do this much minimum. And if you have extra time, then you can do anything. You can play, you can sleep, you can talk to your parents, you can talk to your friends also. But the minimum condition must be satisfied, that your homework and your classes must be properly attended and done. So if that is satisfied, then it is a reflexive relation. So here also, if this minimum property is satisfied, that every element is connected with itself, then that is enough for this reflexive relation. After that, if something else is happening, no issue, right? So I'm again going to define three relations. Let's say R2 is 1, 1, 2, 2, 3, 3. R3 is 1, 1, 2, 2, 1, 2, 3, 1. Now quickly tell me which one is your reflexive relation, which one is not your reflexive relation. All three are reflexive relation. Then why did I write? Why did I take so much effort to write all these things? Only first is reflexive. R3 is not reflexive. Chatutiya says R1 and R2. This one also R1, R2. Okay, quickly see. In R3, 1 is connected with itself, 2 is also connected with itself, but where is 3, 3? I said the minimum condition is every element must be connected with itself. That means in this R3, this minimum condition is not satisfied. It is not a reflexive relation. Okay? Okay, Vahini, we'll discuss. Ravi, wait. Now, if we look at R2, then every element is connected with itself only. One is connected with one, two is connected with two, three is connected with three, and nothing is connected with any other element except these. That means it is an identity relation or not. I just taught you identity relation. Every element is connected with itself only, right? So tell me whether R2 is your identity relation or reflexive relation. Santosh, type publicly. Yes, Hanu. Yes, Vahini. Katuteja, both. Yes. Yes. R2 is an identity relation as well as your reflexive relation because this minimum property must be satisfied. We already know it is a identity relation, and for reflexive relation, this minimum property is getting satisfied in R2, so it is reflexive relation also. And in R1, if you see in the R1, 1, 1, 2, 2, 3, T, 3, it is satisfied. After that, 1 is connected to 2, 2 is connected to 3, not an issue. So R1 is also your reflexive relation. Is it clear? Clear, good. Quickly copy, then I'll rub this off. From this point 2, I can write a property, all identity relations are reflexive relations also. All identity relations are reflexive relations also. If it is satisfying the property of identity relation, then reflexive relation property is automatically getting satisfied. So all identity relations are reflexive relation also. But can I say the reverse also? That all reflexive relations are identity relation? No. Very good. So this concept is clear to you. Very good. I'm happy with you all. Now understand this. This is the difference between identity and reflexive relation. So generally question comes on this concept only, this difference only. Okay. So you must be, if you have already understood, then obviously you can take the correct option. Okay. So I can write it here, but converse is not true. Converse means the reverse thing. It is not true. So I'm going to rub this part. Now let's come to another relation. Symmetric relation. Symmetric relation. Try to understand this. It is also a very easy one, but you need to understand the concept. Let's say your set A has 1, 2, 3 elements. Okay. Let's say your set A has 1, 2, 3 elements. And I have defined a relation in which elements are like this. Let's say 1 is connected to 2. Okay. Let's say 2 is connected to 3. Let's say 3 is connected to 1. Or let's say this much. Understand this. Symmetric means, let's say if I'm talking about two friends, okay, A and B are friends. So I can say A is friend with B. I can also say B is friend with A, right? So I can say A comma B or B comma A. Okay. If I define a relation that A and B are friends, so if A and B are friends, that means B and A are also friends. Do you agree? If A and B are friends, that means B and A are also friends. Definitely. Right? If I give you an example of MS Dhoni and Virat Kohli, both these are friends together. So if Virat Kohli and Dhoni are friends, then Kohli and Dhoni are also friends. If you reverse their position, then also they will remain the friends. So same thing is happening here. If in a relation 1 comma 2 is the element, then 2 comma 1 must also be the element of this set. Okay. If 1 comma 2 is there, then 2 comma 1 also be there. Okay. If 2 comma 3 is there, then 3 comma 2 must also be there. Okay. Do you understand this? If A comma B, then B comma A must also be there. If A comma B is not there, then we don't need to talk about B comma A. Do you understand this? So I'll give you example in which if A comma B is element of relation, then B comma A must also be the element of the relation. If A comma B are the relation, yes, what I'm telling you. Wait a second. That is the important point that I'm going to introduce. If A comma B, focus on this word if this is happening, then only this can happen. If this is not happening, then we will not talk about B comma A. Okay. If A and B are not friends, then we cannot talk about B and A, right? So if 3 comma 1 is not in this set, then we cannot talk about 1 comma 3. Okay, understand this. If 3 comma 1 is not here, then you cannot talk about 1 comma 3 also. We can talk about 1 comma 3 only when 3 comma 1 is already present. Remember this. If it is present, then only you can interchange their places. We introduced 2 comma 1. Why? Because 1 comma 2 was already present here. We introduced 3 comma 2 because 2 comma 3 was already present here. Do you understand this? I'll give you example. You will understand better. Let's say I'm defining a relation R1 having element, let's say 1 comma 2, 1 comma 3, 2 comma 3, 3 comma 2, 3 comma 1, and 2 comma 1. Is it an is it a symmetric relation or not? It is a symmetric relation. Chaturteja say yes. Vahini, Hanok, Sainath, Santosh, Deepak, everybody is saying yes. Tejasvi also says yes. I'm not sure. I don't even remember what I wrote here. See, if you talk about symmetric relation, then first check the elements. Let's, if you start checking elements, then first you will check the first element. We see, okay, 1 comma 2 is already present there. So by this property, if a comma b is element, then b comma a must also be element. So if 1 comma 2 is there, then 2 comma must also be there. If 2 comma 1 is not there, then it cannot be it cannot be symmetric. So check whether we have 2 comma 1. Yes, we have 2 comma 1. Okay, so for the first element, it is satisfied. Now 1 comma 3, 1 comma is 3 there, then 3 comma 1 also must be there. 3 comma 1, yes, 3 comma 1 is also there. Now 2 comma 3, that means 3 comma 2 must also be there. Yes, so it is a symmetric relation, definitely. It is a symmetric relation. Similarly, if I write 1 comma 2, 2 comma 1, 3 comma 1, 1 comma 3, and 1 comma, or let's say 3 comma 2. Is R2 a symmetric relation? No. Why? Because if we see 1 comma 2, then 2 comma 1 is there. Now 2 comma 1 is also there, then we can again check it. Now reverse 2 comma 1, then 1 comma 2, 1 comma 2 is also there. Okay, fine, no issue. These two elements are making a pair 1 comma 2 and 2 comma 1. So no issue, satisfying the property. 3 comma 1 and 1 comma 3, they are again making a pair. So it is again satisfying a property. But this element 3 comma 2, it is not satisfying the property, right? Because where is 2 comma 3? So it is not a symmetric relation. Now, if I give you one more example, a very straightforward example. Quickly, is there symmetric relation? Yes, Chatuteja, 2, 3 is not represented. So that's why it is not a symmetric relation. Now, tell me R3, whether it's a symmetric relation or not. Anok says no, Vaini says no, Chatuteja says yes, Deepak says yes, Vaini says no, Deepak says yes. Yes, no, 50-50. Which one is it? Ravi says, Charita says, Santosh says yes, Deepak says yes. See, always look at the property. If A comma B, then B comma A. Now, A and B are both equal. Okay, so both are 1, 1. If you reverse it, then again you will get 1 comma 1. If you look at this, you have A comma B. B comma A is also 1 comma 1. So that is the part of this relation. 2 comma 2. If you reverse it, again you will get 2 comma 2. So that is part of this relation. 3 comma 3, it is a part of this relation if you reverse it. So it is again a symmetric relation. Yes. Identity relation are also symmetric relation because it is satisfying the property. Don't remember like this, but that identity relation is also a symmetric relation. Don't remember like this. Remember like the property. If 1 comma 1 is there, then 2 comma 2 must also be there.